Okay, so here I'm going to try to explain sort of the experiment that's going on. What we are doing is we are taking a sample of a gas, and we are going to calculate the R constant. The way we're going to calculate the value for R is we are going to measure the big four. We're going to measure the temperature, the number of moles, the volume, and the pressure of a sample of gas. And then knowing the big four, we can calculate that gas constant R. So the way we're going to do this is we are going to make a sample of gas, and it all has to be the exact same sample. So the sample we're going to take is from a butane lighter. Now the butane lighters have butane, which is C4H10, and we've sort of taken off the stickers and such. And what we're going to do is we're going to put a sample of gas in a tube called a eudiometer tube. I know you can't see this all this well, but you just trust me that it's sort of like a test tube-like thing. It's got graduated numbers along here that represent volumes. It's sort of sealed on one end and open on the other end. What we're going to do is we're going to take this entire tube, we're going to fill it completely with water. We're going to put it into our fish tank, then take our lighter, stick our hand in there, and sort of blow butane bubbles up into the eudiometer tube. When the eudiometer tube is filled with water, what's going to happen is the gas that's going into the eudiometer tube is going to push all that water out. So all of the entire sample of gas is going to be inside the eudiometer tube, which we're going to measure the volume of. Okay? So the way to do that is we want to make sure everything's sort of at the same temperature. We're measuring it. So here I have a tube, and you'll notice that I've completely filled it with water, and I have a stopper on the end, and there's no air bubbles in there. And so I'm going to put it into my fish tank, and then sort of take off the rubber stopper, drop it down there. Okay? Now, for us to get our the number of moles of butane, we are going to do that by measuring the mass of butane that is released. The most effective way we need to know what the mass of butane that went into our eudiometer tube is. So what we're going to do is we're going to measure the mass of our butane lighter before and after. So our butane lighter is going to get wet because we're putting it in here. So before we measure it, we're going to dry it off and then spray it down with some acetone. Dry that off, blow it dry, because we need our butane lighter to be clean and dry whenever we measure its mass. So we measure the mass before. We take our eudiometer tube, which is completely full, put it underneath, put the sort of like where the gas comes out is that little brass nozzle there. Put it underneath, put it such that the nozzle is in the tube, and then press our little button. And then hopefully you see that the gas is going up and slowly pushing the water out. So we're going to let that go for a while. We're going to fill it up until the volume is, somewhere greater than 85. So here is my other tube, sort of like in the future. Alright, so there is my liquid level there. So we've run it, we've put our gas in there, and now we take our butane lighter out, we dry it, we spray it down with acetone, and we get our mass. Okay? So now we have our mass of butane that we put in there, because we know the mass of the butane before and afterward. The temperature, we're going to sort of let everything sit and be stabilized with the rest of the room. And we have this barometer, which here at the top, or it's a barometer and a thermometer. At the top it says the temperature is 24.0 degrees Celsius. So we're going to assume that everything is the same temperature. So we know our temperature. We know in degrees Celsius. We convert that in Kelvin. We know our mass of butane that has been put in. And we know, so we can convert that into moles of butane. So we've got our number of moles. All right, so the volume and the pressure are still an issue. If we look at our eudiometer tube, I can arbitrarily move this tube sort of in and out of the water. And if I look at the volume of the liquid level here, when it's down here, it looks like it's about 90.50 milliliters. But if I read the volume when it's up here, it's like 91.3. So it makes a difference as to where it is. What we're going to do is we're going to make our math easy because we need to know we need to know what the volume of this gas is. We also need to know what the pressure of the gas is because we need both volume and pressure. So to make it easier, what we're going to do is we're going to adjust the tube. We actually need the total gas pressure inside the tube to be equal to the total gas pressure out here on the fish tank. And the only way to guarantee that is to make the liquid levels the same. If you think about, when we define pressure, the pressures are the same or the liquid levels are the same. So we're going to make the liquid levels the same. So I'm going to adjust this. And then what I'm going to do is, while it's right there at the liquid levels, is I'm going to put the stopper on. Because as I adjust the tube up and down with the stopper off, the volume will change. So while it's there level, now I put the stopper on, because now what I can do is because the stopper's on, the water level's not going to change, is I can take it out and very carefully stick my head really close to it and say, yes, the volume is 91.20 milliliters. So now I know the volume, 91.20 milliliters. And now all that's left is, what I have to do is figure out what the pressure of butane is. So I know the volume of the butane, the number of moles of butane, the temperature of butane. Now, when we made the liquid levels the same, what that means is inside the tube, I have two gases. I've only got the pressure of the water vapor and the pressure of the butane gas. I have the water vapor pressure and the pressure of butane gas. Because the liquid levels are the same, on the other side I have atmospheric pressure. That's the pressure over here pushing down in the rest of the fish tank. So I know, because my barometer says that right now, that the vapor pressure, or the atmospheric pressure, the pressure pushing down the gas, is 980 millibars. So I know the pressure of the atmosphere is 980 millibars. The pressure of the water vapor, the vapor pressure of water, that's a table value. I can look that up. You might have done that for a pre-lab question. So I can solve for the pressure of the butane, because I need to know what the pressure of the butane is in my tube. Not the total pressure, just the pressure of the butane. Because again, we're trying to figure out the gas law constant, so we need to know the temperature of the butane, the number of moles of butane, the volume of the butane, the pressure of the butane. So once we solve for that, now we can go ahead and calculate our value of R. Good luck.